Okay, welcome to a video about annuities. Here we're going to look at this question and we're going to try and use our ideas of annuities to try and solve it. So what this is a question about Jenny, who puts aside $20 at the end of each month for 3 years. How much will she have then if the investment earns 8.2% per annum paid monthly? Okay, so I think it's important firstly to break down this question. There's some important information that we need to figure out. Name, kind of important, not really. She's putting in $20 at the end of each month, and that's important, for 3 years, and she's putting it every month, so that's actually 36 months. How much will she have then if the investment earns 8.2% per annum, that is per year, paid monthly? Okay, so there's certain bits of information that we need to take focus on, okay, typically the ones that are underlined, which will affect how we solve this question. So the first thing I want to look at is this rate, okay? It's 8.2% per annum, per year, and it's paid monthly, okay? If this is what it is for an entire year and is paid monthly, well, that must mean there's 12 increments of this broken up that is paid monthly. Think of it as you've got some kind of pie and you break it up into 12 bits and it was 8.2. You're trying to figure out how much is in each bit. So just here, I want to figure out what the rate will be. So if we change this into a decimal, we would actually write it as 0.082. Now we want to divide this by 12, okay, per month. This is what it is per year. We want to change it to per month. So let's divide that by 12. And what we're going to get is a really small number, 0.082 divided by 12. It's 41 over 6,000. Really, really small. Now, there's a slight catch to this. When you're looking at this style of question, this is an investment, okay? So it's going to be growing over time. That means there's actually 108% per annum, which we didn't quite cover, which we didn't quite look at. So there is a small adjustment we need to do this. If we use this fraction to figure it out as our rate, it will diminish significantly. Let's just say, look, 20 times 41 over 6,000, it's just our first one, it's going to give us, look, not even $1. Okay? What's important here is this is actually needs to be 100%. And for this to be added on as a 1, you need to plus 1 to this. So if we were changing this, it would be 1 plus 41 over 6,000. And if we do that, 1 plus 41 over 6,000, it's going to give us 6,041 over 6,000. That means in this portion, this maintains the 100%, this 6,000 here. And this 41 is the small, small little growth that we see each month. Okay? So this 41 over this 6,000 with the 6,000 is our small, our small little growth. Okay, that should make sense. And if we do that for every little month, it will grow just a little bit each time. Okay, so rather than just putting the money into a piggy bank, we're getting just small increments of growth in this investment account. So what we actually need to deal with is our rate is going to be 6,041 over 6,000 per month. Now, something that's also important is we have 36 months, And we're also going to be looking at this as $20 at the end of each month. Now, one of my students asked me why that was important today. It's important because at the start of each month, if you put money in a bank account, in this case $20, for that entire month, that is getting interest applied to it, or gets some kind of accrued some kind of value. In this case, it's a very small amount. If you're putting it at the end of that month, that money hasn't had time to have a rate applied to it to increase in value. Hence, with this question, in our first month, we're actually not applying any rate to our first deposit. So that'll make a little bit more sense as we go through the question. So I'm going to start, and hopefully I can explain as we go. Our first month will be 20, okay? Because at the end of our first month, let's say January, she puts in $20, and nothing is affected by that because it's at the end of the month. If she puts in another amount, it's going to be, well, the previous month's times 6041 over 6,000 plus $20. So what this is whatever was in the previous month, we know it's 20 and we'll come to that in a second, it's the rate times that, it's going to be in there for an entire month, and then she's putting in $20 at the end of each month. So this is thinking, okay, whatever's in the bank account, apply the rate, and she puts in $20, which doesn't get applied to the rate. Now, if I'm just going to quickly expand this, I just want you to develop how it's going to look. Okay. Now, we should see a little pattern here where they both have 20 in them, and that's going to be a common factor later. Let's move on to month 3. Well, month 3 is going to be, well, whatever is in there month 2 times a rate. Sorry, my 6s aren't very clear. Plus 20. Okay, so what was in the bank in the second month, first and second month, whatever is accruing, is going to be applied to our rate plus our 20. Now, what's in our second month was this. Now, I'm just going to expand this. So I'm getting a bit low on my sheet. What this is going to look like is it's going to be 20 times 6041 over 6,000 plus 20 times 6041 over 6,000 plus 20. So this part is here. Our A2 is within our brackets, and we're going to times this whole thing by our rate. So some people got a little bit confused about this today. It's timesing by that because these are bound by this times plus times by that. So that's what we're doing, we're timesing. And if I do that, I'm going to have something like this. 20 times, when this times this, we could put it in twice again, or we can just put this in brackets and do it squared. It should be the same thing. And here we can start to see a pattern. This is to the power of 2. Should make that a little bit clearer. 20 times our rate to the power of 2 plus 20 times our rate plus 20. Okay, we can start to see a pattern here. And we can also see that this is A3. The most up-to-date one is this 2, or forward one, sorry, and that's 1 less than our month. And then it seems to decrease every time. It's 2, 1, and then nothing. To the power of 0 in some ways. So let's take this one more step. If we were to use this same logic and do A4, it would be 20 times 6041, 6,000 to the power of 3, plus 20, 6,041 over 6,000 to the power of 3. Whoop, sorry, 2, plus 20, 6041 over 6,000 plus 20. So what this is what the accruing factors are, plus what you're putting in at the end of the month. And we can start to see a pattern here. They've all got 20 in them, and if we group them together as a factor of 20, we can put all these together. So let's do that. It'll be 20, bracket, let's put little times in there for some white people. I'm going to put this one at my front. So 20 times 1 would give me 20, so that's going to be 1 there, plus my 6,004 without any indice, so 6041 over 6,000, plus my 6041 6,000 squared, plus 6041 6,000, sorry, 3, close bracket. And we've got this pattern here. Okay, so, and I just want to go off the rails just for a moment here, just so things are clear. I can keep doing this, and this would be more applicable to other questions, with my AN. Okay, it doesn't matter what month I want to apply to. The question says 36 months, but if I wanted to go for 54 months or 100 months or 1,000 months, I'm going to write an equation that can dictate this. Okay, and what's important just here is this part here is a geometric series, with our first one being A, and then it's going up in these very small increments, and it's being applied to that every single time. If you think about it, this rate is being times by 1, then times again, then times again, then times again. So this is our rate just here, and this is our first initial amount. So we have a geometric series in here that we have figured out using a factor of 20. So let's just break this down. If we were to do it to any number that we wanted, any period, or 1,000 months, we can write this as 20 times 1 plus 6041 over 6,000 plus 6041 6,000 to the power of 2, and we would go plus, and this would keep going until we reached, and remember, number is always 1 less than our number, or the number of period that we're looking at. So what this would be is n minus 1. Okay, just in case, I'll just point it out very clearly. If this is our 4th month, the most that this can go up to, it will have 4 little things in here, but that would always be 1 less number. Okay, so if this is a 5, this would be 4. If this was 6, it would be, if this was 6, this would be 5. Okay, so if any number we put in here, this indice will be 1 number less. Okay, that's a pattern that we've identified here. So here we've got our rule. Okay, now this is any number into which we go to, but we can write a rule for this geometric series. Okay, and then we can sub in our 36. So I just want to looking at this, our first initial our first initial term, I guess you could say, is 1, and the rate in which is times to this and this and this and this is 6,041 over 6,000. So just taking this part, I was going to go A is 1, and our R is 6041 over 6,000. Okay, now I am going to use an equation here, and it's going to be the sum of formula. So make sure I do this correctly. Yep, which is, just quickly recall, Sn over A Rn minus 1, close bracket, all over R minus 1. Okay, I'm going to use this sum of formula in here, okay, to determine this. And then, whatever I get, I can times by 20. So, in here, my first is A, or A is going to be 1, sorry, mind blank, and my R is going to be this rate. And I can put these in to this. I don't need to know N right now. I'm just kind of teaching you how to do it, and then we're going to put in our 36 in a moment. So, let's do it. Our AN is going to be 20 times, let's do this. Our A is going to be 1. I'm just going to put that in just for you guys. Bracket. Our R is going to be 6041 over 6,000 to N minus 1 all over our rate 6041 over 6,000 minus 1, close bracket. Okay, this is our formula for solving any month we want using this question or this problem. Now, the question says for 36 months, but I just want you to spend a moment to meditate and think about this and how we got here, because this methodology of coming to this is really important and is very, very common in HSC style questions. And putting it in terms of AN, some questions will give you what AN is and says prove to it. There is a little bit of a trick. Sometimes questions change and get rid of this denominator, which I'll look at in another video. But I just want you to know how you've got there. And if you've got any questions, just leave them in the comments. But let's try and answer our question. But this is the part, and this methodology of how we came to this is very important. Okay, our last little step is we're putting in for 36 months. Okay, that's our time. We're going to use this exact same thing, and just for N, we're going to put in 36. Well, you know, it's going to be the same result. 1 times 6041 over 6,000 to the power of 36 minus 1 all over 6041 over 6,000 minus 1, close bracket. Okay, and I'm going to put that on my calculator. 20 times, let's put it to the side so you guys can see, bracket, I'm not going to times the 1 because it's going to be the same, 6041 over 6,000, close bracket, to the power of 36, minus 1, close bracket, divided by, open bracket, 6041 over 6,000. If you can tell, I do like brackets, just makes it easier. And there we go, $813.16. Okay, so just the way I'm trying to get my students to set this good habit. There's our answer, but we should write it out as a sentence. So because we were given a sentence question or a worded problem, we should probably answer it in the same way. So Jenny will have saved, and please use dollar signs here, $813.16 in her investment, in her bank account over 36 months. Okay, and that's how we kind of answer that annuity question. I really want to do one where we change the denominator because I got a little bit confused about that. But I hope this answers your questions about how to do annuities and just getting into the habit of doing it. Typically in an exam, they do want you doing this and breaking it down. you should also really develop that habit. One little thing I should mention, I should have done ... between this, because going from 4 to n is kind of a big deal. Okay. Anyway, I'll leave it there. I hope you enjoyed this video.